All right, today we're going to do something a little different. We're going to decode the hidden architecture of a single extraordinary number. So here it is, 65,377. Now, if you're a mathematician or a cryptographer, you probably recognize this number immediately. It's the largest known Vermont prime, and it's basically a cornerstone of the digital security that protects, our daily lives online. But what if it's more than just a number? There's this fascinating analysis out there that suggests it has a hidden structure, a whole story just waiting to be told. And this story connects geometry, cryptography, and, get this, even theoretical physics. Okay, let's dive right in. So here's our game plan. First, we'll cover what makes this prime so famous in the first place. Then, we're going to explore this proposed map of its environment, break down its internal structure, follow a path right to its core, and then, at the end, we'll try to piece it all together and figure out what it all means. All right, so first things first. Before we get into the really wild side of this analysis, let's just quickly go over why 65537 is already kind of a mathematical celebrity. Okay, so it's what's known as a Vermont prime, a really special type of prime number. It has a specific form, 2 to the power of 2 to the n plus 1. And get this, we only know of 5 of them. That's it. This unique property has some seriously cool implications, like it solves this ancient geometry problem. Turns out you can actually draw a perfect 65,537-sided polygon using just a compass and a straight edge. I mean, who knew? But on a more practical level, it's a total workhorse in RSA encryption. Why? Because its binary form is super simple, which makes all the complex math that keeps our data secure lightning fast. Okay, now we're getting into the really interesting part, the new analysis. To really wrap our heads around 65537, the source material says we need a completely different kind of map to navigate its world. And that map is called the 36 modular prism. Just imagine it's like a special filter. It organizes all numbers based on their remainder when you divide them by 36. What's cool is that this process creates just 12 possible channels where prime numbers can even exist. Every other path? Well, those are blind spots, because any number on them is going to be a multiple of 2 or 3, which means, by definition, it can't be prime. And this is where it gets really cool. So you take 65,537, you divide it by 36, and what's the remainder? 17. So it lands right in the 17th channel, which this analysis calls central and highly resonant. But wait, it gets better. What is the number 17? It's also a Vermont prime. It's like the number's address in this system reflects its own fundamental nature. Kind of like a fractal pattern just emerging from the prime landscape. The source describes this so beautifully. It calls this prism the stage for a grand adventure. The primes aren't just these static, boring points on a line. No, they're like explorers, navigating this landscape that's defined by these channels and always avoiding the blind spots. It's not static, it's a dynamic, almost living system. Okay, so we've got our map. Now we can zoom right in and start to dissect the number itself. And what this analysis finds is this stunning internal symmetry. So the idea is that 65537 is held in this state of perfect balance by 4 symmetrical processes, which the analysis calls arms. Now, these aren't physical arms, of course. They're 4 distinct mathematical operations that, when you look at them all together, reveal the number's incredible stability. So 2 of these arms, think of them as a kind of mathematical reflection. They connect the number to the really fundamental symmetry of the hexagon. Then the other 2 arms explore its positive side, including its relationship with its neighbor, 65539. Now, even though 65539 isn't prime, the analysis suggests it casts what it calls a shadow resonance, like a faint echo that actually helps to find the perfect structure of 65537 next door. How cool is that? And that brings us to what might be the most incredible part of this whole thing. The analysis lays out a process that systematically strips away the number's layers. The best analogy is like a physicist cooling an atom down to its ground state, all to find its fundamental essence. It's this very specific sequence of operations, all tied to powers of 2. And with each step you take, a fascinating new connection pops up. The very first step links 65537 to what's called a Mersenne number. Then the next step connects it to a Mersenne prime. It's almost like you're taking a journey through a hall of fame of special famous numbers. So keep following this process, a few more steps, and this cooling process always, and I mean always, terminates at one single incredibly significant number, -24. And look, this is not just some random result. The number 24 is a deeply meaningful constant that just keeps showing up in the weirdest places in advanced math. It's even famous in physics. It's the number of spatial dimensions needed for a specific version of string theory to actually work. It really seems to be a fundamental piece of our universe's mathematical fabric. And this right here is what brilliantly illustrates what makes 65,537 so special. See, if you try to apply this same process to a composite number, say the semi-prime 2001, the path is messy, it's impure, it wanders all over the place and ends up at some non-fundamental value. But the path for 65,537, it's clean, it's direct, and it leads straight to a universal constant. That's a huge sign of its profound structural integrity. So what does this all mean, right? We've gone on this journey from geometry to cryptography all the way to a fundamental constant of physics. How on earth does it all connect? Well, the source actually coins a term for this connection, the groove of the primes. The idea is that there's this underlying rhythm, a stable pulse, in how prime numbers are distributed across the number line. Now, this is tied to one of the biggest unsolved problems in all of mathematics, the Riemann hypothesis, which basically predicts this deep, non-random order to the primes. And in this view, 65537 acts like a perfect metronome for that universal beat. And to make this a little more tangible, the analysis even gives us these physical analogies. Think about it like this. Vermont primes, like our number 65537, are like perfect crystals. They're solid, ordered, and incredibly stable. Composite numbers, they're more like a liquid, just flowing around these solid anchors. And that crystalline structure, that's exactly why 65537 is so reliable for cryptography. It's a point of maximum order in an otherwise chaotic numerical world. So in the end, we're really encouraged to just abandon the whole idea of 65537 as some static, boring object. Instead, the analysis wants us to see it as a dynamic, mobile probe, one that's actively navigating a complex universe of numerical forces, and it's perfectly tuned to the fundamental resonances of that universe. This whole journey, from a familiar prime number all the way to a fundamental constant, it really leaves us with a provocative thought, doesn't it? Maybe some numbers aren't just quantities. Maybe they're frequencies or structural blueprints, or maybe even keys to a deeper code that underpins reality itself. What do you think?